Now we're on to chapter 4. We're going to get more involved in the work here, because what we're going to do is take that monolith application here and move some functionality out of the monolith so we can constrain what it's doing. We won't develop further within the monolith other than to say if we revise the microservice for inventory, we'll point the monolith to go get inventory from that microservice. So future services in our migration will build in terms of inventory first, and then in the next chapter we'll talk about the catalog, and they will basically replace functionality within the monolith, the strangler pattern. So they're advising me here so I don't make mistakes to go ahead and close up my monolith source tree, open up the inventory tree. I'm just going to follow that down source main Java. There we go. And what we'll do is take a look at the project structure here. We got a RESTful endpoint that's going to be written in Java here for the requests coming in. Then there's an inventory logic here in Java inventory database, and then Panache caching facility, which has some really interesting benefits beyond just the caching. In fact, one of the things it'll do is it'll provide an incrementing ID, record ID for the database, so that's all handled automatically. And to do this, use this, we need to add some extensions. So there's actually a Maven build command that'll put the extensions in here. We're adding the object relational mapper, Panache, Java database connector to H2 in-memory database, and a micro profiler called SmallRye for health monitoring. Okay, that worked. We were hoping to get 3 green check marks. And now we're going to create an inventory entity. So there's an inventory Java file right here. That's all done for us. And if you're interested, please work through the details if you'd like. But there's a placeholder file here for the class. And it describes more detail, what all the caching and such is done. Then there's an inventory resource class that we're defining presently. Put this in the empty file. And then that provides 2 REST endpoints, the inventory for the whole inventory, everything in the store, and the inventory by item ID. For example, we'd call that with the item ID to get back the quantities. That's all built in here. Now we're going to need some data. So to get into inventory database, there's a resource file which will hold this SQL. And when we run the build, it'll load the database with this inventory information. Lastly, we need to describe to the application how Quarkus, which is the supersonic subatomic Java implementation we're working with today, which really does a great job of making compiled code with high execution speed and very, very, very small containers for fast startups. It's kind of an essential path to getting to serverless type of deployments with Java. So there's Quarkus. Go back here and put that into application properties. Here's how Quarkus you work with the database, including my secret password and the name of the database we've seen before. Okay, now we're going to run the application. This will do a build, and there's something pretty snazzy that's going to happen here. doing the build. And if I open this link on port 8080, it's not there yet, but if I refresh, there's the inventory. So we see a web representation, the web page for the. Okay, the inventory is here. I just have zoomed in so far, I can't really see the web page. I'm going to stay zoomed in so you can see what you can see. But if I expand this, there it is. So the item IDs, the quantities, and warehouse location. So that's good news. The inventory is working in the Quarkus environment. Okay, let's close that. And the next thing we want to do is, beyond seeing the inventory here, is to do a curl. Make a call here that we want to see the whole inventory. So I'll need a different terminal. I have one here. Control V. And there's a JSON representation of the inventory we saw that curl brought down. So that's very good. And now, how do we make sure that this application's healthy? Well, when we imported the health extension, a default endpoint was defined of health. I'll make a call against that. And we get good news. The status is up, and the database connections health check is up. So we didn't have to define anything for there, but if we wanted more elements of the health check, we could define more. In fact, we will. We'll create a health check here in the inventory health check.java class. And if we actually look at this, we'll see what is done in terms of making the calls to check the health check. So let's go ahead and put that in inventory health check Java. Now you're probably wondering, to see the results of that, wouldn't I have to recompile and restart the application? The answer is no. It's been running, and if you take a look, it did a hot replace of the code. It recompiled it and restarted itself in a fraction over a second. And if I make the same call again, I see, yeah, here's my connections health check, but then here's my successive inventory health check that it defined. So what I'm trying to say here, rather inarticulately, is that this is a dynamic live coding capability. So you've seen this in other types of environments in the past, not traditionally in Java, but all we've got to do to tune this up and work with it interactively is make our changes in the code, and they're instantly reflected in the application. And that we basically need to stop now, because we're gonna deploy this into OpenShift like we did with the monolith. So now I'm gonna stop that, because I want to extend the project file here to tell the application, hey, it's going to use the Postgres connector and OpenShift. There we go. And then we're going to add the following to application properties. Some variables we're defining here to say, in production, we're going to be using my secret password and all these characteristics to access the database at port 5432. And then here's what we're doing in terms of certificates and Kubernetes and deployment target and such things. So I'm going to add those to the application properties. And see how these are the settings for dev. In dev, we use H2 in memory database. In prod, we use PostgreSQL. And now we'll deploy this to OpenShift. We're going to add a database for the backend because we're expecting Postgres, right? And when we invoke this build, start the application, it's going to go ahead and load up, just like it did for H2, it's going to load up PostgreSQL. So I'm going to go in and request a Postgres ephemeral instance. That'll prevent us from having to worry about mapping dynamic storage for this workshop. That's just plain good enough. And we'll tell it that we're going to have a service named database service inventory. My secret password, that's not a variable. My secret password is really, literally, my secret password. So let me order this from the self-service store here. I'm going to add this, and I'm going to add this in the inventory project. Now, I have to be kind of careful that we do things from the proper project or it just won't work. And PostgreSQL ephemeral instantiate. So this is, we said inventory database. You can tell I've done this workshop before because it comes up with those suggestions right here for the code I need. But these are the elements. Okay. And now we don't see the monolith anymore because we changed projects. So if we were in CoolStore Dev, we're not anymore. And there's our database. It's deployed and there's a running pod. Now we're going to deploy to OpenShift. So we're going to tell OpenShift, hey, use project 34, and then do this Maven build. Entering the build onto an image and pushing it into the registry, the local caching registry. And the next step is to monitor the rollout. So the rollout's happening. If I click on inventory, I can see, hey, the build's complete. And then it's deploying a pod, which has the container. And I can see it's all starting up. Java is starting. Now to verify that that's completed, I have this rollout with a watcher flag on it. It'll tell me when, okay, it's actually done. And we see it's done. Now I'm going to label this with some annotations here and labeling. so that we got the proper icons and the representation that the business logic here actually uses the database. If I click on this, I've got the inventory. So the inventory appears to work. It's no longer running in the foreground. Now it's running in a container in a pod on OpenShift. And I can see if my health checks are working here in the container. Yep, just as it did before. And now I can play with the health a little bit here. I'm going to set some a probe timeout. What I really want to do is set the timeout so that on the initial delay, when we bring the pod up, we're not going to test it for 30 seconds while it starts up and gets warmed up and get going. And then we're going to take a look and see what the settings are. And we can see right now the liveness. So these are how our probes are set up. Liveness represents that the whole thing is running, that the container is running. Readiness means a flag in terms of is it able to accept responses. So we have a delay before we start probing. The response time for a success threshold is 10 seconds. This test is done every 30 seconds. 1 in a row succeeding is a pass, 3 in a row is a failure, and we either restart the pod or mark it as not ready. Now, we're going to make sure we have that store open, the inventory open again, because you see it says status OK. And the reason is it's polling. It's doing one of these refreshes. And what if we just killed that process within that pod container? If we go ahead and run this, we're going to go back and take a look at our inventory. Still okay. It's dead. Now, it would be nice. Oh, it did. It self-healed. So the platform knows, the Kubernetes platform knows that, hey, you wanted a pod. You set a deployment configuration that specifies with a replication controller, one pod is to be running. If it becomes 0 pods, or if the pod is still there, but the application fails a health check sufficient number of times, it'll replace that pod. So what it did is it rebuilt a new pod and started it back up. So you got an inventory pod running here. Now we're going to set the probe back to a more production ready set type of setting here with the values, and we've done our first bit to separate out functionality from the monolith by separating out the inventory. Now the next chapter we'll separate out the catalog.